Okay. Oh. All right, so let's talk about the midterm first. Midterms, about a disaster. Unfortunately, it didn't go super well. We had the app. It holds up well during the semesters when it's a lab of like 20, 25 students. Unfortunately, we apparently hit some threshold over the summer. There's too much traffic, and we're exposing some significant slowdowns, significant delays in it. Unfortunately, so I added the 15 minutes to the exam. That's meant to account for that. So if you've waited for less than 15 minutes, then you effectively get bonus time on the exam. But I think, it's hard to tell just from the everything self-reported, but I do believe that some of you did wait more than 15 minutes. So I don't think the 15 minutes is enough. Plus, the 15 minutes doesn't account for any of the pain and anguish that you suffer from sitting there agonizing if your submission is going through. The midterm is already a stressful situation, so I can't do anything to account for that, the extra stress that you unfortunately go through by having the app. I got hair in my face. By having the app slow down like that. So I can't do anything for that, unfortunately. But what I can do is something on the grading side. I'm going to do something on the grading side because I don't think the 15 minutes was enough to accommodate for how terribly the app performed. So I'm going to do something. I don't know what that is. Yeah, it was not fun, Jason. I agree. If it's any consolation at all, it was not fun for me either, having to, because there's like nothing I can do at that point. Like I'm in crisis mode the whole time, but like I can't like go up to the server and turn a crank and get it to go faster. Like there's nothing I can do at this point during the exam. There's obviously things we can do before the final. We can get into the code, figure out what the bottleneck actually is. I think it's with submissions when it's so many students submitting at the same time, and because there's 4 separate submissions. I think that's what ultimately did it. And then each submission is taking long enough, which we usually don't feel when it's 20 students making one submission, but when it's 44 students in this section, 44 students making 4 submissions, it's enough of a load that it's exposing the bug, or not bug even, but exposing the performance issue. Shared crisis mode. It sucks. That wasn't fun for any of us. But so looking forward, I do have to get today's lecture in. So unfortunately, like the easiest thing would be for me to just say, well, we can have another half hour or so. But I do have to get this lecture in, or else you're not gonna be prepared for task 6. And then we're just going to have another crisis down the road because none of y'all will know how to do task 6. Then I have to be like, well, watch last semester's lecture. Those things run through my head. Like, I could do that, but I don't think it's fair to not lecture on required material during a semester. So I want to make sure I get this lecture in. So you do have to stop working. You shouldn't be working on it anymore at 12:45. But if you are waiting for a submission, if it's still loading, trying to submit, you can wait that out. I'll give, at least like a 5-minute buffer. If a submission was made 5 minutes late, I'll give you the benefit of the doubt that you were waiting for the submission to just go through and that you did stop working at 12:45. We had a pretty big slowdown in the middle of the exam, and then again at the end. I assume at the end, just because everybody's submitting at the end. Of course, we're going to have a lot of submissions simultaneously and see the slowdown again. But there were portions where it was going fairly smoothly, so a lot of y'all did get it in. But anyway, so moving forward, and I told the other section this, I'll try to say it the same exact way, is when I analyze all the data, because I have a pretty good picture of what happened here and what's going on, but once I see all of the submissions, see how everything panned out in the end, then I'll make a decision. I'm not going to make any decision right now, but I'll make a decision after that. There will be something to accommodate for this. I just don't know exactly what that's going to look like yet. So I don't want to give any speculation, any specifics about what that'll look like. But the vague-ish thing that I said to the other section that I'll say here is I don't have to follow the grading exactly the way it's spelled out in the syllabus, where the way the application objectives are handed out. I don't think again, I'll take a look once I have all the data. I'll make a decision. But I don't think I have to do any changes to the learning objective. I think everyone was still able to have ample time to do at least classes 1 and DS1. If that's false, I'll see that on the other side, and y'all can talk to me about that if that affects you. But I think y'all had ample time to do at least those two, so I don't think I'll have to change any LO stuff. But for AOs, the way AOs are calculated for the midterm, I think that has to change. That I have to give some accommodations, especially for DS2. In the 8 a.m. for sure, but I think it was the same thing here, that DS2 was the trace that most, if not all of you did last, which is the best strategy. You should have done that one last, the way it was spelled out. That's why it was the last link as well. But that one absorbed most of the issues, so at least for DS2, something has to change there. So I'll handle that on the grading side. I'm committing to grading by tomorrow night, so you will have grades out by tomorrow night, before I go to sleep tomorrow. My reasoning for that is I'm expecting y'all to do the programming tests in 2 days. I think I should hold myself to that same standard and get the midterm graded in 2 days. So grades should be out tomorrow, and so by then you'll know my final decision. If I have that decision made sooner then grades are released, I might send an email and say what that decision is going to be, how I'm going to adjust the grading, just so you have a heads up, just so you know. But something has to change, because it was just unacceptable. I can't give an exam like that and not make some changes, some consolations on the grading side. So I'll come up with something that's fair to everybody. That's going to be my goal in whatever I come up with, and fair to all the different situations. Some students had longer waits than others. Some students will submit whatever they have at 12:45. They'll submit partial submissions. Some of y'all, I blows my mind, but some of y'all might have continued working past 12:45. And then they'll just say, "Oh, I was waiting on it to submit." So I got to take all that into account. I don't want to I don't want to just take what the final submissions are, because that's disadvantage to the students who are honest enough to stop working at 12:45. So a lot of things I got to take into consideration when I make that decision. But my vaguish answer is the AOs won't be calculated exactly the way it's spelled out in the syllabus. It will be softer than that. Okay, but I do have to get today's lecture in, so we can't talk about the midterm the entire time. If we were, I would just gave you the entire lecture time to do the midterm. That would have been an easy solution. So let's talk about task 6. All right, I got to shift gears here. So task 6, we're going to be parsing CSV files. We have the songs.csv, movies.csv, and movie ratings.csv. And we're going to go through the formats of each of these. Songs.csv, each line is going to be in this format: song ID, artist, title, the 3 strings that are required by the song constructor, and then reviewer ID and rating to represent one rating for this song. And in this file, songs can be in the file multiple times. So if a song was rated multiple times, there will be multiple lines with the same song ID, artist, and title with a different reviewer ID and possibly a different rating as well. Movies.csv, each line is going to be in this format: movie title, and then any number of cast members. There has to be at least one cast member for each line, so you can assume that the cast list is not empty. There must be at least one, but there can be any. There could be 50, thousands, 1, 2. Could be any number of cast members here. With this, each line should be treated as a separate movie. So there won't be, in any of my testing, there won't be any duplicate movie titles. If there were, those should be treated as different movies. If there are duplicate titles, those should be treated as different movies. I won't have any duplicate titles. You shouldn't have any duplicate titles in your testing, just to keep testing a little bit simpler. If you do, my solution code will treat each of those as separate movies. Until we get to movie ratings, then things get a bit confused, and the test will be a little ambiguous if you have multiple movie titles. Movie ratings is going to be title, reviewer ID, rating, and this is how we're going to get ratings into our movies. And this is where the titles will be unique and will match the titles from the movies.csv. And what you'll write in this in this homework are 3 methods that'll read exactly those 3 file formats. So those 3 file formats, parsing all that CSV data and getting them into data structures, that's our goal for this. So read songs, the first one is going to read that file in the format of that songs.csv and return an array list of songs. The key with this one is that songs can appear multiple times in that file. If a song does appear multiple times, you need to return one song object for that song with all of the ratings for that song added to it. So the first time you see a song, you'll create the new song and then add this rating to that song. The second time you see that song, you have to have code that says this song already exists and I need to add this rating to that song object that already exists. So songs being rated multiple times is the key part of this method. That's the key thing that you should be thinking about. Otherwise, it's parsing CSV. You've done that in 115. It's not too much more difficult than that, but we do have to go to the heap, manage our references properly, which brings it up to a 116 level. Read movies is a little bit simpler. This one, since you can assume every movie is only in there one time, or rather you can assume each line is a separate movie, even if they have the same title. But again, I'm not testing with movies with the same title in this file. So each line of the data is going to be a separate movie. So you go through the CSV file, each line, create a new movie with this information, stuff it into an array list of movies, and then ship that array list of movies. Send that array list of movies out as your return value. How many mistakes can we make to still be considered passing? I've been over this quite a few times. I haven't before, and I don't now have any specific answer for you. Like, I can't just say 5. There's no specific number. But if your mistakes are not related to the learning objectives of the course, then I generally let those slide. But if they are related to the learning objectives of the course, then even a single mistake could be. Like, if you miss one super constructor call, that's a major mistake, and that's an easy fail. But if you don't cross out any of your stack frames, and you don't have any return arrows, I'm going to allow all of those mistakes and still pass you if you have everything else right that's related to the learning objectives of the course. Because those other crossing out your stack frames and return arrows, those were 115 learning objectives. You should still do those properly. You should still know that stuff. But I'm not going to fail you for those in 116. So that's my shortish answer for that one. And then read movie ratings. This one's a little trickier. This is where not too tricky. I shouldn't say it like that. This is going to take an array list of movies as well as the name of the file that you're reading. And this array list of movies is intended to be an array list that's returned by read movies. You can think of it like that. And that's going to be our use case in task 7, is that this array list will be the output of read movies. So if you think of it like that, it can make it a little easier to understand what this one is. So this will be an array list of movies that don't have ratings but have title and cast lists. And then you're going to read the movie ratings file, which will have title, reviewer ID, and rating. And each time you see a movie in this file, in the movie ratings file, you'll check your input array list to see if you know about that movie, if we have the cast list for that movie. So if this is a movie in the input array list, then you want to take that rating and add it to a movie in your output array list that you're going to eventually return. And the same thing that applies to the songs, reading songs, applies here. If it's the first time you've seen that movie, you probably want to create a new movie object with the same title and cast list as the input array. If it's the second or subsequent time that you've seen that movie, you want to add that rating to the existing movie object, or however else you want to handle this one. There are a few different approaches, but that's the one I recommend. If it's the first time you've seen the movie, create a new movie object. If it's the subsequent time, add the rating to the existing movie object. And then the extra part on this one is if you have a movie that's been rated that's not in the input array list, you ignore that rating. And if there's a movie in the input array list that has no ratings, that movie should not appear in the output array list. So what you return, the movies that you return are only movies for which you know the entire cast list and has at least one rating from the movie ratings file. And I already said that movies can be rated multiple times. I said that. And there's one more thing. Let me check the chat. I believe for one quiz on DS, I evaluate the value is never greater than the result in accident for one case on accident. If everything is correct, would that count as a pass or fail? I'm not going to make more. I'm not just going to do this all lecture, making pass-fail decisions. I'll do that during grading. So by tomorrow night, you'll know the answer. If I read that right, if it is just a mathematical error, and it's clear to see in your diagram that it was just a mathematical error, then that's still going to be a pass. As long as everything that's important, I said I wasn't going to answer it, but I'm going to anyway. For the one quiz DS, you didn't say DS1 or DS2, so it's hard for me to even answer this one. But for both of them, it's did you do the recursion properly? If you did the recursion in the right order, then you should be good with a mathematical error. And you have the structure, the data structure in memory in the right order and everything. Like for the linked list, I can give away solutions now that everything's over. For the linked list, for both versions of the linked list question, one of the nodes wasn't used at all. So making sure that you have one of those nodes just hanging out, not being used, isn't part of the recursion, isn't part of the linked list. Like that's one of the big things I'm looking for there. Is the tree in the right structure? If you don't have the nodes, the left and right going the right way every time, that's bad. If you're not going through the tree, visiting the nodes in the correct order, it was a pre-order traversal. If you're not going through a pre-order traversal, that's bad. But if you have all those things, you can make a lot of other mistakes that aren't related to trees and recursion in linked lists. You can make a lot of mistakes there, and I'll be like, yeah, but you understand your data structures, so I'm good. It's the data structures quiz. It's not the greater than or less than quiz. Okay, so with this, with your test and utility method, you're comparing two array lists of movies, which will be the return value from either of your movie methods. You want to go through these two array lists and make sure they have all of the same movies in them. This is a huge part of this assignment. One is duplicate movies, duplicate songs, making sure you get all the ratings for that song or movie in the same object. That's one huge part of this assignment. The other one is this comparing to array lists. So we want to compare array lists of movies and see if they have all of the same movies. We want to make sure they have movies with the same titles, same cast, same ratings, but the order can be, they can be in any order. And that's the big thing. That's the big thing, the new testing concept that we're going through here. This was started with, right from task 1, the idea that a method can have multiple correct solutions. We're taking that up to the extreme with this one, where the correct solution is the correct movies, but in any order. Which if there are 10 movies, you have 10 factorial, right? That's right? 10 factorial different orderings for those movies, and you have to accept any of those solutions, any and all of them. So checking if two array lists have the same values, but in any order. That's what we want to do. And you have to do the same thing for songs. I don't force you to, I don't require you to, but I do strongly recommend writing a compare song array list method that does the same thing with songs, because it'll make it easier to test your read songs method when you get to testing these three methods. And then finally, in your testing requirements, we have to test methods that take file names as their parameters. So creating test files is going to be a big deal. The data files that I give you for samples are rather large. You're not going to want to build test cases with those. It'll be way too tedious, way too laborsome to do that. What the intent is that you create your own test files that are usually subsets of the files that I give you. You don't have to make up your own data. You can if you want. But you can take just a few lines from the files I give you. And for the movies, I like to trim down the cast list too. Trim it down to like 2 or 3 cast members to make things a lot simpler on that front too. So it's easier to generate my expected values, my expected data structures, so I can stuff them in my utility method. But those testing files should be in a directory called data with a lowercase d, lowercase a, lowercase t, lowercase a. in the root directory of your project. So right in the root directory of your project, right click on this, go to new directory, and add your data directory right there, and then put your files in that directory. Actually, I think I create that for you now, because I had too many issues in the past, which was like 2 issues, but I think that's too many, that I just create that directory. If I'm not mistaken, I think I just have that in the handout now. So use that data directory and put your test files there. Add a student. Everything was great. Their code was great. Everything was beautiful. Beautiful testing, all that. They had a capital D right here. And then every time they submitted to Autolab, it said your test failed a correct solution. And that was their issue. They had a capital D instead of a lowercase d. But Autolab is looking for a directory with exactly this name. So it didn't find their directory, and my correct solution just thought none of their testing files existed. So I don't like seeing things like that. It has, whether checking if this is a capital D or lowercase d has nothing to do with the learning objectives of the course, and it's just a frustrating thing that wasted the student's time. I don't like seeing that. So make sure you don't change the name of that directory. If you change the name of the directory I give you, that one might be on you. But when you have to create the directory, I don't know, I feel a little guilty for that one. That's something that I can have structure that avoids that. So you put all your stuff in there, and then in your test, you should give it a file name like this. Make sure you have data / and then your file name to get into that directory, or else you might get into the wrong directories. Oh, and I had this one too. Don't use testing file names with spaces in them. That caused a pretty big issue last semester. It was the first time I ran into that. Most students don't put spaces in their file names. Like, all my examples have underscores instead of spaces. Treat them like variable names. Don't put spaces in your file names. In computer science in general, whenever I see a space in a file name, man, I get nervous because I've seen way too many bugs caused by spaces in file names. I get nervous. Okay. And I am going to do things a little different. Just because we have such a time crunch, I wasn't going to have much time for this lecture anyway, and now we have even less time because I expanded the midterm by 15 minutes. So I am just going to do exactly what I did for the 8 a.m. We're just going to go through the slides and then look at code that's already been written in IntelliJ. I'm not going to go through any live coding, just due to time constraints. There's a bunch of points that I want to make sure I hit, and I know I can get my timing down if I do it like this. So let's do it. So how are we going to do task 6? And just very brief review. I don't have time to spend on this too much, but very brief review from 115. Hopefully they said all this stuff and you remember it all, and I don't have to do this much. I can speed through this. But everything in your program is stored in memory. We talked about stack and heap, and everything has been stored in stack and heap. The problem with stack and heap, and memory in general, is that it's destroyed when your program ends. Once you hit the end of your program, everything's off the stack. Every stack frame has been crossed out, and then everything on the heap will be garbage collected and just destroyed. Everything's gone. There's no trace of your program after the fact. So if you want data that persists, we have to go to disk, and that's going to be files. So if we save something to a file during the run of our program, that file will exist after our program ends. We get that persistent storage. Likewise, we have files that exist before our program starts, and then we can read those files. And we're only going to read files in 116, but those files will exist before our program starts. They don't have to be in memory or in the stack. And then our methods are going to go to disk, read that data from disk, and load it into memory, into our data structures. And then our program will start working with that data in our data structures, which are in memory. So let's read files in Java. Here's the simplest way that I've found to read files in Java. There are many other ways. I'll give this disclaimer right now. There are many other ways to read files in Java, and most tutorials, if you just Google how do I read files in Java, most tutorials, Stack Overflow answers, courses, if you took AP CS, they probably did it the other way. Most of them will do it the same way, and that's going to be reading it with a file buffer, a file reader that's going to buffer the inputs. It's a little more complicated to do it that way. Y'all could handle it that way. I could do it that way, and it wouldn't be that big of a deal. But it does detract a little bit from the points that I want to make. So we're going to do it the simplest way. If you want, by the way, if you want to use a buffered reader, knock yourself out. Your task 6 is still going to work just fine. Autolab's going to be happy with it. But if you want to read files in the simplest way, just use this. Use this method. You can actually just cut and paste this method from the examples repo. So let's break this down and see what this is doing. First, we're using the paths class, which has a static method named get to convert a string into a path. So we're using strings to represent our file names, but Java has no way to directly read a string as a file name and load all the contents of that string. We have to go through 2 steps to do that. Step 1 is converting that string to a file path. This is going to parse your string, look for any slashes, and treat those as entering a subdirectory. And the last part of the string after the last slash will be treated as the file name. It'll parse all that and figure out the exact path on your file system to the file that you want to open. Then we have files.readAllLines. ReadAllLines is a static method of the files class that we're importing. And this is going to take a path, open the file at that path, read all of the contents of that file, load it all into memory all at once, and then return a list of all of the lines of that file to us. This is unbuffered, so if your files are very large, that's where you would have to use the buffered way of doing things like everybody else on the planet does. Like, I had to dig to find this read all lines method. It's not readily available out there. But if your file is very large, this is going to be very, very bad. It's going to be very bad for your program, especially if your file is, say, 20 gigs and you only have 16 gigs of memory. Like, you just can't load that entire file into memory. You technically can, but you have to use what's called swap space, which treats part of your hard drive as more memory, but it's very, very slow. We don't want that. Then it'll start feeling like the midterm. We don't want that. So that in that case, we would have to buffer. Our files are small enough in this course that we can load them in memory. They're on the order of megabytes, which is, sounds like a lot, millions of bytes, but it's really not that much to a computer. So we're going to get away with unbuffered in 116. So that's going to return a list of strings where each string is a separate line in the file. And if you don't want to think about what a list is, this is a data structure that we haven't talked about. Well, I say data structure, but it's actually an interface that's inherited by other data structures. For what it's worth, ArrayList does implement the list interface. But if you don't want to think about any of that, of what I just said, some of that will make sense on Tuesday when we talk about polymorphism. I will talk about interfaces. But if you don't want to think about any of that, I recommend doing this. Just new ArrayList. The ArrayList constructor can take a list as an argument, and that'll give you an ArrayList with all those elements of the list in the ArrayList. So if by doing this, we can not think about list and just use ArrayList like we have all semester. If you want to use the list directly, knock yourself out. I ain't going to stop you. But if you don't want to think about it, just new ArrayList. And this is the same constructor that we've used when we do arrays.asList. That returns a list with all the values that we give it, and then we stuff that into the ArrayList constructor to work with ArrayLists instead of lists. But there's a big problem here. So I left a huge part of this program out. If we try to run this program, assuming we put the rest of our class here, if we create the class definition, create a main method, call read file with some file name, Java will not run this program. It won't get past the compiler. Compiler's going to say, I ain't running that code, because this code is dangerous. This is very risky code to run because we don't know, like, this file name is just any string ever. It could be hello world. It could be absolutely anything. There's no guarantee that it corresponds to an actual file on disk, which is a big problem. Because if that file doesn't exist, this program is going to throw an exception. It's going to throw an I/O exception. So let's take a quick side note to talk about what exceptions are. We've seen them all semester. Null pointer exceptions, I dare to say most of you have probably seen it at one point or another when doing test 3 or test 5, if you somehow got through test 3 without ever seeing a null pointer exception. An index out of bounds exception you might have also seen if you try to access an element of an array list that's not a valid element, any negative integer or any integer the size of the array list or larger. It's going to throw an index out of bounds exception. Invalid key exception, also with maps, if you try to get the value of a key that doesn't exist in the hash map, you'll get an exception. And if these exceptions are not caught, if you have an uncaught exception, that's going to crash your program. Your program just stops and says uncaught exception, gives you your stack trace, which is where you were in every stack frame. At that point, all the stack frames that were on the stack, and the last stack frame that was on top of the stack that threw the exception, it's going to tell you the exact line that threw the exception. Then you click that line, you go to that exception. I should throw assertion error on here too. Your JUnit testing is going to throw assertion errors whenever a test fails and give you the stack trace. And Stack Overflow errors. Some errors versus exceptions. Errors can't be caught. If you have a Stack Overflow error, you can't catch this. Your program's just going to crash because you ran out of stack space. You can't recover from that. Program's crashing. Exceptions can be caught though. So what do I mean by that? What do I mean by an exception can be caught? Is we're going to use a new way of control flow called a try-catch block. And we're going to use the keyword try and then put in braces a code block of any risky code that we want to run. This is code that might throw an exception, and we're going to add a catch block to say if an exception was thrown, then run this code. So what this will do is it will try to run the risky code. It'll try to run this, and at any point, if this code throws an IO exception in this case, it's going to stop running the code. It's going to stop running this, just wherever it is in the execution, it just cuts it off and says, nope, no more. And goes to the catch block and runs this code instead. So if this file name doesn't exist, we're not going to return a new array list with the lines of the file. We can't do this because throughout this process, an exception is going to be thrown. So we catch that exception. I missed a little bit here. So we catch that exception and then run the code in this catch block. We're catching an IO exception specifically here. That's what you'll get if the file doesn't exist. But you can catch different types. If you have different exceptions that you expect to be thrown, you can catch different ones. You can even have multiple catch blocks in the same try. So if I have two different exceptions that might be thrown here, I can have two catch blocks to catch either one of them and do different things depending on which type of exception was thrown. We're not going to do that in 116. The only try-catch we're going to do is exactly like this. Try-catch IO exception for reading files, for files that don't exist. And then if the file doesn't exist, we're going to have some default action here. So instead of crashing our program when a file doesn't exist, or in this case, not even compiling, we're going to return an empty array list if the file doesn't exist. And our program can go along with whatever it was going to do. Whatever it's going to do with that data, it'll just have an empty array list instead of an array list with the lines that it expected because it was an invalid file name. So there was no data there. We're going to return an empty array list. Okay, that's reading files. We're not going to write files, so just file reading. And the files that we're going to read are all CSV files, so let's talk about CSV files. Now you parse CSV files in 115. I don't think I have to dwell on the format too much. The way we're going to parse CSV files is going to be splitting on commas. Now I have to give another warning here. This isn't the right way to parse CSV files. I feel bad every time I say this. Maybe we'll fix this in a later semester, but not this semester. This isn't the right way to parse CSV files. You don't just split on commas and call it a day. The problem with this is, what if your data itself contains a comma? What if there's a comma in your data? You're going to split that data in half and treat it as two different values instead of one value that contains a comma. So this is bad. We just can't have commas in our data. That's too limiting. Not the right way to parse CSV. For 116, we're going to get away with this. I washed all of the song data, all the movie data, all the cast lists, everything to not contain any commas. So we can just split on commas and keep it simple. For actual CSV parsing, if you have a comma in your data, the protocol says surround that data value, the entire value, in double quotes. So if you see double quotes, you ignore all commas until you see the next double quote, and that'll say, okay, everything in between those was one single value that might contain commas, and it will contain commas, or else why have the double quotes? And then it's, well, what happens if my data contains commas and double quotes? In that case, we have to escape any double quotes in that double quoted value, and we do that by a backslash. So if we see backslash double quote, that's an actual double quote value, not a double quote that means this is the end or beginning of a value that contains commas. And having you code all that just seems cruel, so I'm not going to do that. So we're just going to split on commas, and I'll wash the data. Not that you couldn't handle that. You can all handle parsing, writing code to parse all that, CSV, everything I just said. But it really detracts from what I want you to get out of 116. That's more of a 115 problem. 115 could ask you to do that and it'd be fine because it's loops, it's variables, it's all 115 stuff that you would be using to do that, not 116 stuff. But maybe in the future I'll have you pull in a CSV library and just call the library and let it do its thing. CSV parsing libraries exist in Python. They don't exist in Java, so we would have to pull an external library, which can add a little bit of complexity, and I'd have to pick out my favorite library. I'd have to shop around and all that, so it's a little bit of a pain. So we'll just split on commas. We're not learning CSV. CSV doesn't show up in the learning objectives of the course anywhere. It's all about it's really all about testing values in a data structure that's unordered. That's really the learning objective of Task 6. But we want to refresh some 115 topics too. I already said it when we introduced the homework, but and keeping track of your references and making sure the ratings go in the right object by reference. Those are the two things that are the 116 learning objectives of the assignment. So those are the ones I want to focus on, not parsing CSV properly. So that's the why. So we have a split method in the string class, a non-static method named split that takes a string. So we're going to split this string on commas. If the string is A, comma, B, comma, C, line.split is going to return an array with the three values, the values A, B, and C, and indices 0, 1, and 2, respectively. And what's an array? So it returns an array, and I got the same speech that I had for list. If you don't want to think about arrays, how to use arrays, or what arrays really even are, you can convert that array to a list and then convert that list to an array list using this code. If you don't want to use arrays, slap this on there, convert it into an array list, and then use that array list to work with your data. Then you don't have to think about anything else. So if you're like, man, array list, hash map, linked list, trees, and next week graphs, that's enough data structures for me for now. Like, I don't want list and array on top of all that. If that's you, which I don't blame you at all, just stuff these things in the array list constructor and use array lists. If you do want to use the array, again, just like lists, I'm not going to stop you. Knock yourself out. You'll learn a little bit more. Arrays do have the same syntax as lists in Python for the most part, in that you'll use the bracket notation with indices. So if you want to use that and you're fine with that, knock yourself out, go for it. If you don't want to think about it and you want to reduce your cognitive load as much as you can, which you should always be doing as a programmer or just as a human, try to reduce your cognitive load. Slap it in the array list constructor and call it a day. Then you can use .get, .size, all your methods. And some of the data that we're reading as strings, when you read a file, it's going to be strings, at least the ones that we're reading here. It's going to be strings, but some of those strings represent numbers. So we need ways to convert those strings into numbers. Integer.parseInt and double.parseDouble are the ones I'll show you on the slide, I guess. ParseInt is the only one you'll need on your homework. All of our ratings are integer values, And these are the only 3 file formats that we're going to read for this semester. We're going to use data read from these files in both Task 7 and Task 8, but we're going to use these 3 methods that you're writing in Task 6 to accomplish those. So there's only ints, only the ratings are going to be converted into numerical values. Integer.parseInt takes a string. If that string is a well-formed integer, it's going to return an int value for you that you can do all your int stuff with. By well-formed, I mean that it has to actually look like an integer. If it's, say, the string 4, that's not going to parse, and it's going to throw a number format exception, I believe it is. All of the data has been washed. It's all going to be well-formed. All of your tests should have well-formed integers. My code, my correct solution will crash if you give me non-well-formatted ints. It's another thing that I'm going to say, let's not go down that rabbit hole. Let's not worry about it. Like these tests, if I had you worry about proper CSV formatting and poorly formed data and corrupt data, like Task 6 could blow up into a really, really complex homework pretty quickly. It's complex enough. We don't need to do that. So everything's going to be well formed. Write tests that are well formed, and we won't have to worry about that much. And we can focus on the actual learning objectives of the course. And in 4 minutes, let's go up here. So I have some data that I want to read. This is from the examples repo. So if you want to take a slower look at this, I would recommend going to the examples repo and studying this stuff if you want more examples. But I have data in this format. I have a header line that's going to tell us the values, the types of values here. The 3 files for your homework, none of those file formats have header lines. So that's not something we worry about on the homework. But this header line is going to say we have country code, city name, region code, population, latitude, and longitude as our values for our CSV. We have 2 classes which are just going to store values for us. City, which has those values from the file format that we just saw. A constructor to set all those values, getter methods, and a toString method. So no actual logic going on here. This is just a container for data. And then location, which has lat and long, a constructor to set them, and then getters for lat and long. So we have data structures or classes just to be able to store the data from our data files. And then what I want to write is a load countries method, which is going to take a file name that's data in that format, a file in that format that we just saw. And what I want to do is return a hash map that maps every country code to an array list of all of the cities in that country. So the first thing I'll do is create my output hash map that I'm going to return. I'm going to call my read file method, which is exactly like we saw in the slides. That's going to give me an array list of strings. And if you want to just copy this file, this method, use it directly in your code and stuff a file name in it and get the array list of all of the lines in the file, do it. And since I do have a header line, I have to have some way to handle that. So I'm going to remove the value at index 0, which is going to remove that header line for me. That's not something you would do on the homework, but since I have a header line, I have to handle that. Iterate over the lines of the file, split each one on commas, stuff it into an array list. And now I'm going to get the value at index 0, which should be the country code, the value at index 1, which would be the city name, the value index 2, which would be the region, value index 3, which would be the population, which I want to parse into an int, latitude and longitude, which I want to parse into doubles, and then create my location and city, create my objects for that value. Then the next thing is the one I want to focus on in 1 minute. I need to check if I've seen this country before is the big check that I want to make. And this is going to be, have I seen this movie before? Have I seen this song before? So should I add this rating to the existing song or movie? Or should I create a new song or movie with this rating? The same idea here, this is what I'm trying to show you with that, is what I'll do is something called lazy initialization. I'm going to check if my hash map contains this country already. So I'm going to call contains key. Does my hash map contain a key with this country code? If not, then I have never seen this country before, and I'm going to initialize it. I'm I'm going to put into my hash map this country with a new empty array list. And whether this code executed or not, whether this is the first time I've seen this country or the millionth time I've seen this country, I don't care. If I've gotten past this condition and gotten to this line of code, I know that my hash map does contain this country with an initialized array list. So I'm going to get that array list out of my hash map and add this city to that existing array list. It might be an empty array list that I just created. It might be an array list with 1,000,000 cities in it already. I don't know. I don't care. I'm just going to make sure it's initialized and then add the city to that country. I recommend you doing the same thing here. A lot of y'all have different solutions. Whatever solution works for you, that's fine. Some of y'all like to just do array list and have your array list of movies, array list of songs, and then instead of contains key, you would iterate over the entire array list to see if you have that song or movie in the array list already. What I recommend and what I like to do is create the hash map from song ID or movie title to songs or movies. And then I can do contains key. Have I seen this before? And do the same exact thing that I'm doing here. When I'm going to have this resolve to a reference to a song or movie, and then add rating the rating that I have. And then just very quickly, when I'm testing things like this, when you're testing data structures, as always, but I haven't shown too many examples of this in lecture, you have your actual that you're getting from the method that you're testing, and then build your expected. Put all of your data into this expected, which can be fairly tedious. I think that's why a lot of students don't do this, is create your expected with all of the data that you expect. So all of this data that's from my second testing file, which gets a little trickier. I have 3 cities in the same country to make sure that I'm handling multiple cities in a country properly. Create my expected, and then call a helper method that's going to compare my 2 data structures, which will go through all of the values in both of these, all the key value pairs in this case, and make sure they have all of the same values in them. And I'm even using a compare cities helper method to make sure I'm always checking every value of each city, have my tolerance for my doubles, everything in there. And when you're testing data structures like this, the first thing you should do, check the size. If they're not the same size, you're done. It's over. They're not the same. If they're the same size, then what you want to do is go through each value in the expected and check if that value exists in the actual. And if every value in expected exists in the actual and they're the same size, then these 2 data structures have all of the same values regardless of the order of those values. Now these are hash maps, so it's a little different, but for your homework it'll be array lists. You want to make sure that every value in the expected array list is in the actual array list. And since we don't have duplicate song IDs or duplicate movie titles, we do get away with that. Once there's duplicates, there's some extra complexity to it. But we can say same size and everything in expected exists in the actual, then we're good. To do that, there's a little bit of a trick for each value in the expected, finding out if it exists in actual. This is one case where I like to personally use flags. I don't like flags, Boolean flags at all, but this is one case where it does make things a little easier for me, so I do use them. Is I want to iterate through each expected, and at the beginning of that loop, to find if my actual has this value of the expected array list, I'll set a Boolean to false that says, have I found the value before? Then iterate through all of the values in actual, and if I find the value in that inner loop, I'm going to set my flag to true, and then after that loop that goes through all the actual, I'm going to assert that my flag is true. Because if my flag's false, if it's still false after I went through everything in the actual, then I know that that value is not in my actual at all. One trap that students fall into is in that inner loop, they'll assert that the song from expected is equal to the song from actual. But if there's 2 songs that you expect, well, one of them is definitely not going to be your expected song, and you're going to fail that assert and just fail everything all the time. So you want to make sure you're comparing songs in a way that that doesn't fail an assert if the song isn't what you expect, because you want to check, does the song exist anywhere in this array list, not does it occur everywhere in this array list. So those are all my hints and everything. I went 5 minutes over. Sorry about that. I lost too much time with the exam, but I got all the points out there. You can rewatch the lecture. I know I went through that very quickly, but you can rewatch the lecture when you're doing task 6 and pick up on all those hints. Okay, with that, I'm gonna take a breather, go into office hours, and then after office hours, I'm gonna figure out something with this midterm fiasco. Hopefully there's a pretty simple solution, because it looks like most submissions did go through eventually, but I'll have to see if, like a lot of students said they were missing parts of their traces when the submissions finally went through. A lot of stuff I have to look into. I'll be busy with that. So I'll see you. If I don't see you in office hours, I'll see you Tuesday for polymorphism. Take care. How much extra time do you think we're gonna get? Panicking. Wait, why are you asking that now? Yeah, panicking a little. Oh, panicking a little. You're panicking very late. I was about to sign off. None? What? I don't know what you mean by extra time. You got the 15 minutes. That was the extra time. Like, the exam's over. The exam was over at 12:45. So my solution isn't going to be to give you extra time. I'll tell you that much right now. Like, I'm not going to, because I don't think that's fair. I'm not going to say, okay, the exam was a mess, but Saturday at noon, I'm going to give you half an hour to finish your trade. Like, I'm not going to do that because that's not fair. I have to confine everything to lecture time, and there's no other lecture time to really use. So I'll have some solution that doesn't require you to take the exam at some other time. And I do need all the lecture time for polymorph. Actually, we could probably fit a little in polymorphism, but I still think that's unfair. I wasn't able to load the quiz until about 9:45. 9:45 isn't even that bad. Like, you still had... Oh, for the morning. Yeah, that'd be for the morning. No, 12:45. Yeah, 12:45. Yeah, that's bad. But it depends when you first loaded it. I don't know. But like I said, I'll make decisions that affect the whole class. I'm not going to make any individual decisions because everybody was affected the same. So I have to make one blanket decision that treats everybody fairly. Don't know what that'll look like, but not extra time. Yeah, no, I don't want to. I don't like speculating because once I say something, it spreads rumors. Like, sometimes I'm the source of rumors, and I never like doing that. When I hear my own rumors, and I'm like, no, I just said maybe I was possibly thinking of maybe doing that. And then by the time it gets back to me, oh, I heard you were doing this. No. That was just So I don't want to speculate at all as to what I'm going to end up doing. But I will, like, if my final decision comes out and you're not happy with it, I'll definitely give you a chance to air your grievances, and I'll reconsider. All right, take care, everybody. See ya.